Preferred wire color schemes for 280 and 120 volt systems are black for phase A, red for phase B, and blue for phase C. For 480/277 volt systems, the preferred scheme is black for phase A, brown for phase B, and orange for phase C. Control voltage at 24 volts. Alternating current is typically red. Direct current voltage is usually blue. Ground wires should be bare copper. Neutral wires should be white. Dealing with the shared colors issue can be addressed in several ways. Firstly, use colored tape around the wire ends to clearly indicate the correct phase. Secondly, provide a comprehensive color chart that clearly defines the color scheme for all wires in the system. Thirdly, label each wire with its designated phase or purpose to eliminate any ambiguity. Fourthly, if possible, use wires of different sizes for different phases. For example, use smaller wires for control voltage and larger wires for high voltage. Fifthly, run wires in separate conduits or trays to minimize the potential for confusion. Further considerations include adhering to NFPA 79 recommendations for orange or yellow to indicate non-de-energized line voltage. Follow industry-accepted color coding standards to ensure consistency and reduce the likelihood of errors. Consult the manufacturer's documentation for any specific wire color requirements related to the machine. Color coding of electrical wires is essential for safety and proper functioning of electrical systems. Consistent color coding helps electricians and technicians quickly identify wires, reducing the risk of electrical shock and preventing wiring errors. Different voltages and functions are assigned specific colors to distinguish them. For example, in a 120/240 volt system, black typically indicates a hot wire, white is neutral, and green is ground. In three-phase systems, colors like black, red, and blue are common for identifying the different phases. Ground wires are usually green or bare copper. Neutral wires are typically white or gray. Hot wires can be black, red, blue, or other colors depending on the specific application and voltage. When working with electrical systems, it is important to understand the color codes being used and to follow them consistently. This will help to ensure that the system is safe and reliable. Always refer to relevant electrical codes and standards for specific color coding requirements. Wire size, also known as conductor gauge, is a critical factor in electrical wiring. It determines the amount of current a wire can safely carry. Wire size is typically measured in American wire gauge, abbreviated as AWG. Smaller AWG numbers indicate larger wires and greater current carrying capacity. For example, a 12 AWG wire is larger and can carry more current than a 14 AWG wire. The appropriate wire size for a circuit depends on the amount of current that the circuit will be expected to carry. The National Electrical Code (NEC) provides tables and guidelines for determining the correct wire size for various applications. These tables take into account factors such as the type of insulation, the ambient temperature, and the number of current-carrying conductors in a raceway or cable. Using the correct wire size is essential for preventing overheating, voltage drop, and other potential problems. Undersized wires can overheat and cause fires. Oversized wires can be more expensive and difficult to work with, but they will not cause any safety problems. When selecting wire size, it is always best to err on the side of caution and use a wire that is slightly larger than what is required. This will provide a margin of safety and ensure that the circuit will operate reliably. Always consult the NEC and other relevant electrical codes and standards for specific wire size requirements. Conduit is a type of protective tubing used to enclose and protect electrical wiring. It is typically made of metal or plastic and is available in a variety of sizes and types. Conduit provides a physical barrier that protects wires from damage, such as from abrasion, moisture, and impact. It also helps to prevent electrical shock by grounding the metal conduit. There are several different types of conduit, each with its own advantages and disadvantages. Rigid metal conduit, RMC, is a heavy-duty type of conduit that is typically used in commercial and industrial applications. Intermediate metal conduit, IMC, is a lighter-weight type of metal conduit that is often used in residential and light commercial applications. Electrical metallic tubing is a thin-walled type of metal conduit that is easy to bend and install. Flexible metal conduit (FMC) is a flexible type of conduit that can be used in tight spaces or where vibration is a concern. Plastic conduit, such as PVC conduit, is a non-metallic type of conduit that is corrosion resistant and easy to install. The type of conduit that is used for a particular application depends on the specific requirements of the installation. Factors to consider include the environment, the type of wiring being used, and the applicable electrical codes and standards. Conduit must be properly installed to provide effective protection for electrical wiring. This includes using the correct fittings and supports and ensuring that the conduit is properly grounded. Always consult the NEC and other relevant electrical codes and standards for specific conduit installation requirements. Electrical panels, also known as load centers or breaker boxes, are enclosures that house electrical circuit breakers or fuses. These panels distribute electricity from the main power source to various branch circuits throughout a building. Electrical panels play a crucial role in protecting electrical systems from overloads and short circuits. Circuit breakers and fuses are designed to interrupt the flow of electricity when the current exceeds a safe level. This prevents damage to wiring and equipment and reduces the risk of fire. Electrical panels typically consist of a metal enclosure, a busbar assembly, and a number of circuit breakers or fuses. The busbar assembly is a conductive strip that distributes electricity from the main power source to the individual circuit breakers or fuses. Circuit breakers are resettable devices that trip open when an overload or short circuit occurs. Fuses are one-time use devices that melt and break the circuit when an overload or short circuit occurs. The electrical panels must be properly sized to accommodate the electrical load of the building. The panel's ampacity rating must be sufficient to handle the total current draw of all the circuits connected to it. Electrical panels must also be properly grounded to provide a safe path for fault current to flow back to the source. This helps to prevent electrical shock. Electrical panels should be installed and maintained by qualified electricians. Working with electrical panels can be dangerous, and it is important to follow all safety precautions. Always turn off the power to the panel before working on it and use appropriate personal protective equipment. Always consult the NEC and other relevant electrical codes and standards for specific electrical panel installation and maintenance requirements. Grounding is a critical safety measure in electrical systems. It provides a low resistance path for fault current to flow back to the source, which helps to trip circuit breakers or blow fuses and to energize the circuit. This reduces the risk of electrical shock and prevents damage to equipment. Grounding is typically achieved by connecting the metal enclosures of electrical equipment, such as appliances, machinery, and electrical panels, to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode is buried in the earth and provides a direct connection to ground. Grounding systems must be properly installed and maintained to be effective. The grounding conductors must be sized appropriately to handle the expected fault current. The connections must be tight and corrosion resistant. Grounding systems should be inspected regularly to ensure that they are in good condition. There are different types of grounding systems, such as equipment grounding and system grounding. Equipment grounding is used to ground the metal enclosures of electrical equipment. System grounding is used to ground the neutral conductor of an electrical system. Both types of grounding are important for safety. Ground fault circuit interrupters, GFCIs, are devices that are designed to protect people from electrical shock. They monitor the current flowing in a circuit and trip open if they detect a difference between the current flowing to and from the load. This difference indicates that some of the current is leaking to ground, which could be a sign of an electrical shock hazard. GFCIs are typically installed in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. They are required by code in these areas. Arc fault circuit interrupters of size are devices that are designed to protect against electrical fires. They monitor the current flowing in a circuit and trip open if they detect an arc fault. Arc faults are dangerous electrical conditions that can cause fires. They are often caused by damaged or worn wiring. ASIs are typically installed in bedrooms and other areas where people sleep. They are required by code in these areas. Overcurrent protection is a general term for devices that are designed to protect electrical circuits from overloads and short circuits. Circuit breakers and fuses are the most common types of overcurrent protection devices. Overloads occur when a circuit is carrying more current than it is designed to handle. Short circuits occur when there is a direct connection between two conductors that have different voltages. Both overloads and short circuits can cause damage to wiring and equipment and can create a fire hazard. Circuit breakers and fuses are designed to interrupt the flow of electricity when an overload or short circuit occurs. This prevents damage and reduces the risk of fire. Voltage drop is the decrease in voltage that occurs along a conductor due to the resistance of the conductor. Voltage drop can cause problems with electrical equipment, such as reduced performance and premature failure. It is important to minimize voltage drop in electrical circuits. Voltage drop can be reduced by using larger conductors, shortening the length of the conductors, and reducing the current flowing in the circuit. The National Electrical Code, NEC, provides guidelines for calculating voltage drop and for selecting conductors that will minimize voltage drop. Electrical safety is of paramount importance when working with electrical systems. Electricity can be dangerous and can cause serious injury or death. It is essential to follow all safety precautions when working with electricity. Always turn off the power to the circuit before working on it. Use appropriate personal protective equipment, such as rubber gloves and safety glasses. Never work on electrical equipment when you are wet or standing in water. Be aware of the potential hazards of electricity and take steps to avoid them. If you are not qualified to work on electrical equipment, hire a qualified electrician. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years and provides detailed requirements for all aspects of electrical wiring and equipment. The NEC is adopted by many jurisdictions in the United States and is used as a basis for electrical codes around the world. The NEC covers topics such as wiring methods, overcurrent protection, grounding, and equipment installation. It is an essential resource for electricians, engineers, and other professionals who work with electrical systems. Local electrical codes are regulations that govern electrical installations in a specific geographic area. These codes are typically based on the NEC but may include additional requirements that are specific to the local area. It is important to be familiar with the local electrical codes before starting any electrical work. Local electrical codes are enforced by local authorities, such as building inspectors. They ensure that electrical installations are safe and comply with the applicable standards. Wiring diagrams are visual representations of electrical circuits. They show the components of the circuit and how they're connected. Wiring diagrams are essential for troubleshooting electrical problems and for installing new electrical circuits. There are different types of wiring diagrams, such as schematic diagrams and ladder diagrams. Schematic diagrams show the function of the circuit, but do not necessarily show the physical layout of the components. Ladder diagrams are used to represent control circuits and show the sequence of operations. Electrical symbols are standardized symbols that are used to represent electrical components in wiring diagrams. These symbols allow electricians and engineers to quickly understand the function of a circuit. There are a wide variety of electrical symbols, each representing a different type of component such as resistors, capacitors, transistors, and integrated circuits. Understanding electrical symbols is essential for interpreting wiring diagrams. Troubleshooting electrical problems involves identifying and correcting faults in electrical circuits. This requires a systematic approach and a good understanding of electrical principles. The first step in troubleshooting is to identify the symptoms of the problem. Then, use a multimeter or other test equipment to measure voltages, currents, and resistances in the circuit. Compare these measurements to the expected values to identify the faulty component or wiring connection. Once the fault has been identified, it can be corrected by replacing the faulty component or repairing the wiring connection. Electrical testing equipment is used to measure electrical parameters such as voltage, current, resistance, and continuity. Multimeters are versatile instruments that can measure all of these parameters. Other types of testing equipment include ohmmeters, ammeters, voltmeters, and continuity testers. It is important to use the correct testing equipment for the job and to follow all safety precautions. Personal protective equipment (PPE) is equipment that is worn to protect workers from hazards. PPE for electrical work includes rubber gloves, safety glasses, and insulated tools. Rubber gloves protect against electrical shock. Safety glasses protect against flying debris. Insulated tools protect against electrical shock when working on energized circuits. It is important to use the correct PPE for the job and to inspect it regularly for damage. Lockout-tagout (LOTO) is a safety procedure used to prevent accidental energization of equipment during maintenance or repair. LOTO involves disconnecting the equipment from its power source and then placing a lock and tag on the disconnect switch. The lock prevents the switch from being turned on and the tag identifies the person who locked out the equipment. LOTO is an essential safety procedure for protecting workers from electrical hazards. Electrical safety training is essential for anyone who works with electrical systems. Training should cover topics such as electrical hazards, safety precautions, PPE, and LOTO procedures. Electrical safety training helps workers to understand the risks involved in working with electricity and to take steps to protect themselves. Continuous learning is important in the electrical field. Electrical technology is constantly evolving, and it is important to stay up to date on the latest developments. This can be done by attending seminars, reading trade publications, and taking continuing education courses. Continuous learning helps electricians and other electrical professionals to improve their skills and knowledge and to provide the best possible service to their customers. Industry standards are guidelines and specifications that are developed by industry organizations to ensure the quality and safety of products and services. In the electrical industry, there are many different industry standards, such as those developed by the National Electrical Manufacturers Association (NEMA) and the Institute of Electrical and Electronics Engineers (IEE). These standards cover topics such as wiring methods, equipment performance, and safety requirements. Following industry standards helps to ensure that electrical installations are safe and reliable. Specific machine requirements should always be considered. Consult the manufacturer's documentation for any specific wire color requirements related to the machine.